Hello and good day. Today in Algebra, we are covering PO5, the order of operations. And math being one of the few universal languages that we have, no matter where you go, 2 plus 3 will always be 5. 2 things and 3 things will always total 5 things. It might be verbalized differently or written differently, but it will always be 5. And in a universal language such as this, it's important that when we have multiple operations in one equation, we always get the same result, right? 3 plus 4 times 7 would be a problem if it was either 49 or 31. You know, you can't just say, today I feel like adding 3 and 4 to get 7, multiply by 7 and get 49. And then tomorrow you say, you know what, today instead I'm going to multiply 4 and 7 first to get 28, and then add 3 to get 31. Math can't work like that. Okay, so we have what are called the order of operations. Since you've done this before, and since we're all PermDAS people, all on the same page there across the board, which one's right? Which one is the correct answer based on the order of operations? Yes. The right one, as opposed to the wrong one. Yes. The right one. 31, right? Yeah. 3 plus 4 times 7 should every time equal 31 because, according to the order of operations, we would multiply before adding. Okay? But let's run through them all. The order of operations are as follows. This being a key point, feel free to put it on a help sheet. You just want to make sure that you don't forget anything if you were to be asked on a test what they are. The P stands for parentheses. Parentheses. E comes next, and that stands for exponents. R comes after that and stands for radicals or roots. M for multiplication. D is for division. A for addition. And S for subtraction. PERMDAS. Okay? Yes, Luke.
So if you were doing one and it was going, so it's going left to right, does it matter the order of, like, if it's addition or subtraction?
Excellent question. Where folks run into trouble here with the order of operations is they figure it is that order, literally that order, every single time, never deviate, anything like that. So what Luke's asking about is if we have something like 10 minus 4 plus 7, okay, where we do have subtraction followed by addition, and according to the order of operations, we should do the addition first. Okay? Not exactly. All right? Because addition and subtraction are on the same level, right? If we can kind of separate these, addition and subtraction, that lowest level, they're actually interchangeable. Such that if you have subtraction and then addition, that's all you have in the equation, you simply work from left to right. So your first step here would be to take 10 minus 4, which is 6, and then add 7 to get a final total of 13. That being said, however, could you add first if you wanted to? Sebastian, you initially said that you would add first. Tell me more about that.
You could if you put parentheses around it.
Okay, we'll talk about parentheses in just a little bit, but as it's written here, without parentheses, could you add first? I mean, yes, you could. Tell me how. But what? Grayson? Okay, the commutative property says that we can add things in any order, right? So if you wanted to add first, tell me how you would handle that here. Nick?
I would add 10 and a 7 because technically it's a negative 4.
Okay.
That would equal 17, and minus that 4 is 13.
So one option is to rearrange this, right? And put your 10 followed by positive 7, which is 17, and then subtract 4, which is 13.
Well, there's one thing that you could never do, which would be 7 plus the 4. Because that would just mess it up because then you'd be doing 10 minus 11, which would be negative 1.
Yeah. Where people run into trouble here, okay? Thinking that you must add first because A comes before S in the order of operations. If you wanted to add 4 and 7, you're not actually going to be adding 4 and 7 because like Luke said, then you'd get 11, and 10 minus 11 isn't 13. What would you actually be adding? And Nick kind of touched on this too. Colin? It's a negative 4. That subtraction sign is a negative sign that belongs to the 4. So if you wanted to add first, you could by taking negative 4 plus 7, which is positive 3, and then 10 and positive 3, 10 plus 3 gets you to the 13 we already got. Okay? So typically, this would be the most correct way to handle it is just work from left to right, subtract first, and then add. Okay? And the reason why addition and subtraction are interchangeable and they're on the same level is because they are opposites, right? Right? If you start with a number and subtract something, you start with 20 and subtract 6 to get back to 20, you would add 6. Okay? Multiplication and division. If you started at 20 and multiplied by 2 to get back to 20, you divide by 2. They are opposite operations as well. Same thing with the exponents and the radicals. If you start with 7 and you square it to get 49, to get back to 7, you take the root of 49. Right? That's why the R belongs there. So opposite operations up until we get to parentheses. Someone mentioned parentheses earlier. Parentheses aren't actually an operation, but what's their purpose? What's their function? Why are they listed first, Sebastian?
Because you always have to do order in the parentheses first.
They're actually kind of the most powerful thing in this whole order because they have the power to change the order of operations. If you did want 3 plus 4 times 7 to equal 49, you could make it happen by adding parentheses, right? Now that says, no. Don't you go multiplying 4 and 7 first. Add 3 and 4, get 7, and then multiply to get 49. Okay? So parentheses, they do always come first. They have the power to change the order of operations in a given equation. Questions so far? Should be more or less review. Okay. So then your practice part down here. Okay. It says, evaluate each equation. Check your answer by identifying each step. I did not leave you this much room so that you could write your answer super big. Okay. I left you this much room so that you can show me step by step exactly what you are doing to work your way through the order of operations. And what I mean by that is, in this first one, 7 plus 6 divided by the difference of 7 and 1, what are you doing first?
7 minus 1.
Parentheses. So I want you to underline that and then rewrite the expression with that evaluated. So 7 minus 1 equals 6. So you rewrite it with 7 plus 6 divided by 6. Now what would you do? What comes next? Olivia? 6 divided by 6, which is 1. And we're left with 7 plus 1. So you can still write your answer really big if you want to, right? But just not that big.
Not as.
Okay?
Well, that's just me. Mega numbers.
Let's talk about the last one in this front page here. 9 plus 1 in parentheses divided by 3 squared. Can we do more than one calculation in our first step, Luke?
Yes, I'm pretty sure, because it won't make any difference.
Right. We can actually underline both our parentheses and the 3 squared here because one doesn't affect the other. Right? They're separated by division. So whether we do them in separate steps or all in one step, it doesn't change the value. So we have 10 divided by 9, which doesn't work out evenly, but we're in algebra, so that's okay. We have to kind of start getting used to those kinds of things happening. When you get something like this that doesn't work out evenly, it is best practice to write it as the fraction 10/9. Because remember, that fraction bar is really just a division symbol, okay? And the reason for that is because if you were to find the decimal value and you rounded it, 1.1, or even went to the hundredth, 1.11, that's still a rounded value. And like we touched on a little bit in geometry, if we were to use that value again in another calculation later on, if this is rounded and we use it, what's going to happen to our future solutions?
The calculations will be thrown off. The
calculations will become more and more inaccurate, right? If we use 10/9, that being the exact value, then our future calculations will remain accurate, okay? So whereas I would accept this, 1.11 is fine. If you wanted to really impress me and put 1.1 repeating, ooh, great, right? But know that we'll kind of stick with the fraction values as often as we can. Okay? Luke.
If you do 1.11,
That'd be the same thing.
okay, yeah. I didn't know if it was
1.11 repeating would be the same thing as,
okay.
Yeah. If you flip over to the next page, it's going to be similar to what we just did together. And so any of these 8 that maybe if you started to work ahead and come across one that left you feeling a bit confuzzled that you'd like to discuss?
A bit too much to do on your ship.
Nope. Haven't written anything. Sebastian.
For the one where it's 500 minus 4, and then in parentheses it's 7 plus 3 into the second power, would you still do the distributive property even though there's not a variable?
Ooh, good question. So Sebastian's wondering, is it okay here to distribute, because we're called, and you mean with the 4, right? Yeah. He's asking, is it okay to distribute that -4 into the parentheses there?
Not yet.
What operation is distribution? It's multiplication. Is there something else in there that must be done first? Yes, the exponent. So no, it would not be correct to distribute in that -4 because whatever is inside those parentheses is being squared, which must be done before multiplying. So your first step would be to solve the addition within the parentheses. That gives us 500 minus 4 times 10 squared. Our next step would be to square the 10, which is 100. Right? 500 minus 4 times 100. Now we can multiply 4 times 100. -4 times 100 is -400. 500 minus 400, we get 100 as an answer. Okay? McKenna.
For the one in the next row, like below it.
Well, let's come back to that one just a second, okay? Any of the other 7 up in this first section here you want to go over together? We already did 1, so 7 left. No? Okay. McKenna, what's your question about the next section?
How would you like after except for the last one then? When would you put the
Okay, so the whole point of this next section, why it's separate from the top part, is that this focuses now on parentheses and how parentheses can change the value of an expression rather easily. All 5 of these basically contain the same components, right? It's either a positive or a negative 4n and then squared, okay? But depending on where you put parentheses, that can really affect what you need to do first and what the overall outcome is. So what your job is to evaluate each expression when n equals 3. So for this first one here, and we'll get to the last one in just a second, you got 4 times n squared. Replacing n with 3, now you have 4 times 3 squared. Okay? Which, who's got the value for that? What is 4 times 3 squared? 36. 3 squared being 9. 9 times 4, 36. So you might think that, oh, well, the rest of these are going to be 36 or negative 36 over here, but not so much. Okay? So McKenna's asking about the last one here, where if we rewrite this and just replace n with 3, when does that negative sign come into play? Okay? What would we do first here? Let's kind of back up and just take it from where we start. What would we do first? But did you have a thought, McKenna? What would we do first here? Oh, hold on. We'll leave people in suspense. So what would we do first here?
You do 4 times 3.
Okay, so parentheses first, right? So we take care of that. And we don't want to lose our parentheses here, okay? Because we've got other stuff going on, right? We've got the negative sign and we're squaring. That negative sign out in front, this is going to seem like a weird question here, but what operation does a negative sign represent? And the answer is not subtraction. Okay? What operation does the negative sign represent in relation to the 12 here? Or if you have a negative number, yeah. Multiplication by what? Negative 1.
Oh, yeah.
Okay? Negative 1. This would be just as correct to write negative 1 times 12 squared. But if you remember me saying in an earlier lesson that mathematicians are lazy people, it takes so much time to write that 1. We just say, well, we just understand, right? In our language, that's like a contraction. You know, do not becomes don't. Negative 1 times 12 just becomes negative 12. So back to the original question. If we're multiplying 12 by negative 1, and we're also squaring 12, which one happens first? The squaring. So this would be, back up to this one here now, it would be 12 squared is 144, and that negative sign would come down in front. Negative 144 would be your answer. Whenever you are squaring, which really, and you know, this kind of comes in now, these two here, you'll see the difference between the negative sign in the parentheses versus the negative sign outside of the parentheses or no parentheses at all. Okay? That was a very good question that comes up. Luke.
I was originally going to ask, couldn't you just literally do the operations and just put the negative sign on the finished product?
Yes, as long as you understand, you know, don't forget it, why you don't include it. Yes. The very bottom section here, kind of another different way to look at order of operations. Right now, if you were to calculate all 4 of these, none of them would equal 45. However, I would like you to place parentheses in the equation to make it equal 45. So you are not adding any numbers. You are not changing any operations. You are simply adding parentheses to change the order of operations. So does anybody have the solution to the first one? Where do those parentheses go to make it equal 45? Camden?
4 times 2.
Around the 4 and 2?
Yeah.
Like that?
Yeah.
Well, hold on, folks. What's that?
Then you don't need parentheses.
Okay. Well, yeah, so for starters here, since we do the multiplication first anyway, putting parentheses around it, while not wrong, is just not necessary. But again, if we solve this the way it's written here, 60 minus 7 plus 4 times 2, which is 8, that's not 45. 60 minus 7 is 53. 53 plus 8 is 61. Right? So we do need parentheses here somewhere, but it's not around the 4 and the 2. Anybody else have an idea?
None.
Some new voices maybe you haven't heard from? Go ahead.
It's around the 7 and the 2.
Around the 7 and the 2.
Are you kidding
Okay?
me?
Because, folks, because now we've got 60 minus, in parentheses, the 4 times 2 must happen first still. And then 60 minus 15, which is what 7 plus 8 is, gives us 45. So all of these do require parentheses. Some of them, you might use more than one set, and all of them are possible. It would be very, very cruel of me to put one on here that was not possible and make you think about it forever. They are all possible. I guarantee it. All possible. Okay? Before we derail, you've actually done phenomenal the last 20 minutes or so, which you've proven to me that you can, control yourselves during the lesson because you've done an excellent job. But before we derail, any other questions, comments, concerns, complaints, comments, congratulations, criticisms? Yes.
Last question.
Yeah. It's a doozy. Have fun. We will talk about it tomorrow. Okay? Talk about it tomorrow. All right. Your homework is to finish PO5. You also have your math packet due tomorrow. You also have Con due on Thursday. Geometry after school today. It's your time to shine, folks. That is how you math.